Today we're looking at radial surveys. Now radial surveys are these wild looking pictures that have lines and information all over them like this and like this. But don't panic because it's all the skills that we've learned so far in Trig all rolled into one big weird picture. Okay, so they can involve pretty much any of the skills that we've learned so far. It involves bearings, it could involve the area rule, it could be the sine rule, the cosine rule. It can even have right angle trig in there sometimes. Pretty much anything that we've learned this topic can exist in a radial survey. All right, now a radial survey is basically just a compass. See if I've got a north up here with some points drawn on it. And sometimes I have measurements. I don't know why I wrote degrees there. I've clearly forgotten how to write meters for lengths, but anyway, that's okay. So here I've got point B. It's got a bearing of 21 degrees, so that's measured from north. I've got point C, that's at 113, meaning that measured from north down here is 113 degrees. Here is 256 and up here is 310. Now the question is asking me to calculate the length of AB. Now when it comes to radial surveys, it's very easy to get thrown off by all of this overwhelming information. So I encourage you to bring a highlighter to the exam so that you can highlight only the bits that you are looking at to help your mind focus on just the stuff that it needs to. So I'm trying to find the length of AB. So I'm trying to find this length here. Okay. Now, in order to find that length, what have I got going on in that particular triangle? I've got one side down here, I've got another side here. Now, let me outline this entire triangle in blue for you. So I've got one big triangle there. Now this is what I'm trying to find. I'll just call that X. I've got one side, I've got another side, I'm missing a side, but what I don't have is an angle. So I'm really close to being able to use the cosine rule, I'm just missing an angle. So I've got to have a look at the picture and see where I can pull some more information off to help me solve this question. So I can see that here I've got a bearing of 21 degrees. What this means is that the measurement in here from north to here is 21 degrees. All right, so I'm partly there. Now I've just got to figure out how big this section is. So over here, this part tells me that point A has a bearing of 310, meaning that measuring from north all the way clockwise around to here is 310 degrees. So in order to get back to north, this piece must be 50 degrees to give me 360 from there to there. So now I can add those two numbers together to find to find the size of that angle. So 50 plus 21, let me do this in purple. 50, my texter wants to work, 50 plus 21 equals 71 degrees. So this here is 71 degrees. Now I'm just going to draw my triangle out just to help you visualize it. You don't have to do this in the exam, I'm just doing it because I like drawing on the whiteboard apparently. So this here is 60, this here is 75, I'm trying to find X, and I've just learned that my angle inside is 71. Okay, hopefully now you can see that we're going to use the cosine rule because I've got three sides and an angle in the middle opposite the side that I'm looking for. So the cosine rule is, let me write that in a black texter. The cosine rule is c squared equals a squared plus b squared minus 2ab cos c. Okay, let's start by labeling our sides and our angles. So this one here is going to be little c, and this angle is going to be capital C. And this can be A and this can be B. Those two are interchangeable, it doesn't matter which one, little a and little b. So into my formula, I've got c squared equals a is 75 squared plus 60 squared minus 2, and then 75 bracket 60 cos C is 71. Okay, now, in my calculator, I'm going to type this in, 75 squared plus 60 squared minus 2, 75, 60, cos 71, and I get a really big number, but that's okay because it's my C squared. 6294.88661. Now I'm going to click square root around this, 6294.88661, square root, and I get C is equal to 79.34. Technically it's 0 to blah blah blah, but I'm just rounding to 2 decimal places, so 0.34. Cool, and that is the length of my AB. So I could write, therefore, AB equals 79.34, and because these have units, they're meters, this would have to be meters as well. Okay, cool. Now, let's have a look at this question up here. So, calculate the bearing of C. So I've got a bearing for point A, that's 29. I've got a bearing at B, which is 125. Don't know this bearing, but I've got this one up here, and I've got some measurements happening on the inside as well. But one key thing to notice is that I've got an area in here. So I know it's an area because it's kilometers squared. Squared tells me that it's the area on the inside of that triangle. So I must have to use this because that's not usually thrown in there for no reason. But then again, you know, could be. Exam writers, sometimes if they're feeling evil, they might chuck extra pieces of information in there just to mess with you. But anyway, so in order to find this bearing, I'm either going to have to find the size of this angle in here and minus it from 318, or I can find the size of this angle, let me change colours, or I can find the angle in here and add it to 125. So I've just got to have a look around and see what other piece of information will help me to find either that or that. Okay, so let's explore the blue part. If I were to find this angle, I would need to have more information happening in here. I could use the cosine rule if I had a length for this side, because I could go side, side, side to find the angle, but I don't have enough. Could I use the sine rule? No, because I don't have any matching pairs to be able to use. So I can't use this angle in here. There's not enough information in my question. Let's look at this one here. Let's look at the purple side. So I'm trying to find the bearing of this line. I'm just going to go over in brown there. Bearings are 3 digits with a little angle symbol. Now, I'm going to need to find how big this angle is in here. Do I have enough information in this particular triangle to solve it? So looking at this triangle, I've got an area, a side, and an angle in between. That's perfect. It's exactly what I need in order to use the area formula. So the area formula is area equals half times A times B times sine C. Let's put all those pieces of information in. Let me just start by labeling. So I've got the area in here. I've got a little a, I've got a little b, and this angle up here is my capital C. All right, so area equals half times 25 times 16 times sine C. Oops, forgot to put the area in here. Silly me. 198. Okay, so into my calculator, I'm going to type this bit. So half times 25 times 16. So I get 200. So 198 equals 200 times sine C. Okay, now I've got to pick this bit up and move it over here So I'm going to do the opposite of whatever's happening here. They're being multiplied together, so I'm going to divide by 200 to move it. Divide by 200. They get cancelled. So now I've got 198 over 200 is equal to sine C. Okay, now because I'm trying to find an angle, I have to click, shift, then that will give me sine with a little -1 once I hit sine. And then I type that fraction in, 198 over 200. So shift, sine, 198 over 200, close bracket, and I get 81.8903 blah blah blah. So that's to 2 decimal places. Now I'm not quite finished. I found how big this angle is. It's 81.89 degrees, but that doesn't tell me this. I then have to add this angle to this bearing over here to get the final answer. So let me show you what I'm talking about. The whole goal of this question is to find out how big it is from north all the way around to C. Now I figured out this part is 81.89, and from here to this line is 125, and that comes from here. So I've got to add those two together to find out my bearing. So I'm going to go 125 plus 81.89 gives me plus 125, 206. 206.89. So, because I can only use 3 digits to represent my bearing, I'm going to have to round to the nearest whole number. So that means that 206.89 would round to 207. So 207 degrees. Great. And that's how we do radial surveys. So the moral of the story is radial surveys can pull in any skills that we've learned from trig so far. You've got to be really careful looking at your picture, trying to see what other pieces of information will help you solve the question. It could be any combination. It could be area. It could be sine rule. It could be the cosine rule. Really any of it. All right, so study hard and you'll be right. Okay, thanks for watching.